So hi everyone, welcome to the new lecture of thermodynamics. I hope you remember we were discussing closed system, right? So reversible processes in closed system. तो वो part तो already खत्म हो गया हमारा, right? In the last class, one student asked me, sir, can you please write all the equations once so that कौन से equation कहाँ पे use करना है, right? So that we should learn. So first of all, very simple thing, right? So आपको starting from first lecture, you go through the lectures, right? For different processes, we have different equations. Right, so again, those are having still confusion on the equation, right? So in the first 10-15 minutes, we will see what are the equations we have discussed so far. Okay, so then only we are going to start with the open system. Okay, so what are the equations we have discussed previously? ठीक है, so we have started with, right? I am starting with जो pure substances में मैंने पढ़ाया था. I am not starting with that, right? So only for closed system I am talking about. ठीक है, so first equation we have discussed was what? Right, our first equation we discussed was internal energy change for a closed system is equal to del Q plus del W, right? So this is the first equation we have discussed. मतलब अपना जो closed system है ना, right? So this is our closed system. तो इसके अंदर जो internal energy change है, that is due to heat transfer and work transfer. ठीक है ना, यही हमने किया था, राइट? सो आई होप यू रिमेंबर, राइट? सो इफ वी इंटीग्रेट दिस, राइट, इफ वी इंटीग्रेट दिस और इफ वी कैलकुलेट फॉर वन पर्टिकुलर प्रोसेस, राइट, आई कैन राइट व्हाट फॉर वन पर्टिकुलर प्रोसेस माय डेल्टा यू इज इक्वल टू हीट ट्रांसफर ड्यूरिंग दैट प्रोसेस प्लस वर्क ट्रांसफर ड्यूरिंग दैट प्रोसेस. क्लियर? ठीक है, सो दिस इक्वेशन इज वैलिड फॉर ओनली व्हाट क्लोज सिस्टम. ठीक है ना, ये ओनली वैलिड फॉर क्लोज सिस्टम है. उसके बाद हमने क्या डिस्कस किया था, राइट? फॉर ए रिवर्सिबल प्रोसेस आपका जो डेल डब्ल्यू है, राइट, सो दैट इज इक्वल टू माइनस पी डी वी, ये भी हमने डिस्कस किया था. ठीक है, सो हमारा साइन कन्वेंशन के हिसाब से हमने एक माइनस साइन लिया है, राइट? सो आई होप अप टू दिस इज ओके फॉर यू. क्लियर? देन व्हेन यू इंटीग्रेट दिस इक्वेशन for a process 1 to 2, we will be integrating this as 1 to 2 PdV, right? So I hope you remember this as well. ठीक है, so these are the things we have discussed in the last class. We from starting with everything, right? Now उसके बाद हमने क्या डिस्कस किया था? For every process, right? Every process for an ideal gas, मतलब every ideal gas process you have two equation. du is equal to cv dt and dh is equal to CPDT. तो ये जो दो इक्वेशंस है, राइट? सो दीज टू इक्वेशंस आर वैलिड फॉर एनी आइडियल गैस प्रोसेस, राइट? सो विच एवर आइडियल गैस प्रोसेस यू आर टॉकिंग अबाउट, दीज टू इक्वेशंस आर वैलिड, राइट? सो दीज आर द फोर थिंग्स वी हैव डिस्कस्ड. ठीक है, नाउ वी आर गोइंग टू स्टार्ट विथ व्हाट, राइट? सो नाउ व्हाट इज आवर इंपॉर्टेंस? आवर इंपॉर्टेंस इज टू राइट द इक्वेशन फॉर डिफरेंट प्रोसेसेस. ठीक है ना, वी नीड टू राइट द इक्वेशन फॉर डिफरेंट प्रोसेस. मतलब पहला प्रोसेस क्या होगा? कांस्टेंट वॉल्यूम, राइट? सेकंड प्रोसेस क्या होगा? कांस्टेंट प्रेशर. थर्ड प्रोसेस है अपना आइसोथर्मल. फोर्थ प्रोसेस है एडियाबैटिक. दीज आर द फोर प्रोसेस यू हैव, राइट? ठीक है, सो हर प्रोसेस का सेपरेट डेरिवेशन दिया हुआ है लास्ट क्लास में, राइट? सो गो बैक एंड सी दैट पर्टिकुलर डेरिवेशन, राइट? दैट्स ऑल, दैट्स द ओनली थिंग रिक्वायर्ड. ठीक है, सो हाउ वी आर डिराइविंग, आपको पता होगा, इफ इट इज अ कांस्टेंट वॉल्यूम सिस्टम, दिस W will be zero because there is no dV. That is, there is no change in volume. So your volume change is zero. For constant volume system, this del W will become zero, right? Constant pressure, what will happen, right? Constant pressure, what will happen? Your del Q will be equal to dH in constant pressure. Clear? In an ideal gas process, right? In an ideal gas process, your du will be cv dt. If it is an isothermal process, ये दोनों values zero हो जाएगा. क्लियर? सो इन एडियाबैटिक प्रोसेस कौन सा टर्म जीरो होगा? डेल क्यू जीरो हो जाएगा, राइट? सो आई होप आपको यू विल बी रिमेंबरिंग ऑल दिस इक्वेशंस एंड हाउ वी हैव डिराइव्ड एवरीथिंग. ठीक है, सो फॉर एडियाबैटिक, आइसोथर्मल, कांस्टेंट प्रेशर, कांस्टेंट वॉल्यूम, यू शुड रिमेंबर ऑल द इक्वेशंस. क्लियर? सो दीज आर द इक्वेशंस यू शुड रिमेंबर. नाउ कौन से इक्वेशन कब यूज करना है? फॉर एग्जाम्पल, सिंपल एग्जाम्पल, हमने बोला था रिवर्सिबल वर्क डन इन केस ऑफ एन एडियाबैटिक प्रोसेस इज इक्वल टू P2V2 minus P1V1 divided by gamma minus 1, right? Same way you have another equation, N into R into T2 minus T1 divided by gamma minus 1. ऐसे आपको 3-4 इक्वेशंस होंगे, है ना? इन एडियाबैटिक प्रोसेस और इन आइसोथर्मल प्रोसेस यू मे बी हैविंग लॉट ऑफ इक्वेशंस. सो ये इक्वेशंस कब यूज करना है, राइट? सो मैंने ऑलरेडी आपको बोला है, राइट? सो यू हैव टू यूज द इक्वेशन अकॉर्डिंग टू द क्वेश्चन. ठीक है, क्वेश्चन में क्या क्या वैल्यूज दिया हुआ है, राइट, अकॉर्डिंग टू द वैल्यू गिवन इन द क्वेश्चन यू नीड टू यूज द इक्वेशन। ठीक है, अगर आपके पास T1 T2 है और गामा कैलकुलेट कर सकता है, यू कैन यूज दिस इक्वेशन, सिंपल, राइट। आपके पास P1 P1 P2 है, यू कैन यूज दिस इक्वेशन। सो इट डिपेंड्स ऑन व्हाट द गिवन वैल्यू, राइट, इट डिपेंड्स ऑन द गिवन वैल्यू। अगर कुछ भी वैल्यू दिया नहीं है फॉर आइडियाबैटिक, आपके पास तो ये रिलेशन है T2 by T1 इज इक्वल टू P2 by P1 पावर गामा डिवाइडेड बाय गामा माइनस 1। Clear? I don't remember exactly, it was gamma minus 1 by gamma, you can check it, right? So whatever, I think it is gamma minus 1 by gamma, right? Whatever equations we have written, right? So check the relations, right? So if you check the relation and if you can understand that, you can convert it, right? मतलब आपके पास T2 और T1 है, आपके पास एक P1 है, तो P2 कैलकुलेट कर सकता है, right? So you can calculate from the relation, right? जो भी relation आपको पता है, right, उससे आप कैलकुलेट कर सकते हैं। Clear? So this is the meaning. राइट, सो व्हेन वी शुड यूज वन इक्वेशन डिपेंड्स ऑन द क्वेश्चन। आपको कुछ भी रिमेंबर करने की जरूरत नहीं है, राइट, इफ यू रिमेंबर 1 or 2 इक्वेशन दैट विल बी इनफ। ठीक है, बाकी आपको डिराइव करना आना चाहिए, लाइक यू शुड बी एबल टू डिराइव इट एट द टाइम ऑफ एग्जामिनेशन। ठीक है, सो वी हैव सॉल्व्ड ऑलमोस्ट ऑल द क्वेश्चन। उसके बाद हमने क्या सॉल्व किया, नेक्स्ट टॉपिक क्या था, राइट, इफ यू रिमेंबर हमारा टॉपिक था फ्री एक्सपेंशन, राइट। फ्री एक्सपेंशन में क्या होता है, इट इज द एक्सपेंशन अगेंस्ट वैक्यूम, राइट। सो क्या क्या होगा, फाइनली क्या जीरो हो जाएगा, राइट, आई होप यू अंडरस्टूड, राइट, हाउ टू कंप्रेस इट बैक टू द ओरिजिनल स्टेट, वो भी आपने ऑलरेडी डिस्कस किया है, राइट। सो दीज आर द क्वेश्चंस वी नीड टू सॉल्व। क्लियर? सो दीज आर द टॉपिक वी नीड टू डिस्कस। अभी क्या लेफ्ट है, राइट, सो सम स्टूडेंट्स हैव आस्क्ड मी टू सॉल्व 1-2 क्वेश्चंस इन द वीडियो, राइट, ऑल अदर क्वेश्चंस इन गेट इज डन, right, since some students asked me to do this problem in gate, right, on the board, so I am doing that particular question also here. So let me show you the question first. You can see here this is a Gate Academy booklet. So it is 2005 IIT Bombay question paper, common data question, right. So those who wanted to write it, right, write the given value, you can pause the video and write it. Frictionless cylinder piston assembly contains an ideal gas. Initial pressure is 100 kilopascal. Temperature is 500 Kelvin. Volume is 700 into 10 power minus 6 meter cube. This system is supplied with 100 joule of heat and pressure is maintained constant at 100 kilopascal. Enthalpy variation is given by H is equal to, it is given in joule per mole, 30,000, it is not 3,000, it is 30,000 plus 50 T, where T is the temperature in Kelvin. Clear? And R value is given. Now they are asking what is the final volume of the gas V2 in meter cube. Right, so those who wanted to write the question, you can write it. Clear? Now I am moving to the second part of the question. That is options given for final volume is 700. So if the answer is 700, it will be a constant volume process, right? So they have given B, C, D options are also there. And finally the change in internal energy of the gas, right, so this is also given. Clear? So these are the questions given, these are the 2 questions given for 4 marks, right. So I hope you have read the question, so we will solve it now. Clear? So those who haven't written the question, please pause the video and try to solve it. Some students have already asked me, sir, how to solve it, that's why we are doing it in the board. Right, once this is completed, we will be ending our closed system processes, then we can go to what, our open system process. Clear? So these are the options for question 1, and second question is change in internal energy of the gas in joule. Clear? I hope you have gone through the question. So let me write the given values now, then we will solve. So it is a frictionless cylinder piston assembly. So whenever they say frictionless, the meaning is you can take it as a reversible process. ठीक है? You can take it as a reversible process. Now, it contains an ideal gas. So that is also one of your given things. That is, they have given ideal gas. So that is another information they have given. It is an ideal gas. Now, a frictionless piston cylinder assembly contains an ideal gas. Initially pressure is 100 kilopascal. So P1 is 100 kilopascal is given. Now temperature T1 is 500 Kelvin. Third, volume is V1 is 700 into 10 power minus 6 meter cube. Clear? So these are the three initial values they have given, right? A frictionless cylinder piston assembly contains an ideal gas, and they have given three given value. Now the system is supplied with a heat of 100 joule. So heat supplied to the system is 100 joule, right? Due to this heat supply, we have an enthalpy variation, right? But the pressure is maintained constant, so it is a constant pressure process. Clear? It is a constant pressure process. Now enthalpy variation is given by capital H is equal to 30,000 plus 50T, but the unit for enthalpy given is joule per mole, right? So these are the things given. Now the first question is, what is the final volume of the gas? Right? What is the final volume of the gas? V2. That is, initially your volume is V1 700 into 10 power minus 6. Now what is the final volume? That is the question. So first of all, right, what will be the final volume? It's an ideal gas process, right? So for ideal gas, how can we start the question? They are asking what is the final volume, right? What is the final volume? So ideal gas ke liye, you know, it is P1 V1 by T1 is equal to what? P2 V2 divided by T2. यहाँ तक तो पता है सबको, right? P1 V1 by T1 is equal to P2 V2 by T2. Now it is a constant pressure process, so P1 and P2 are equal. So can we write it like this? V1 by T1 is equal to V2 by T2. ठीक है ना? Right? V1 by V2 is equal to T1 by T2. Right? For an ideal gas constant pressure process. ठीक है? लेकिन यहाँ पे क्या क्या वैल्यू अवेलेबल है आपके लिए? V1 अवेलेबल है, V2 is an unknown. You don't know V2 क्योंकि हमें कैलकुलेट क्या करना है? हमें कैलकुलेट ही V2 करना है. So V2 is an unknown. लेकिन T1 तो पता है हमें, right? T1 is there, V1 is there, लेकिन we don't have T2. So आपको अगर V2 कैलकुलेट करना है तो we need the value of T2, right? We need the value of T2, otherwise we cannot find the value of V2, right? So for how to find the temperature T2, that is the question, right? How to find the temperature T2, that is the question. तो कैसे कैलकुलेट करेंगे, right? So that is the first problem. So first step will be always to write the given value, right? उसके बाद हमें देखना है कौन सा प्रोसेस है, which is the process here. The process here is constant pressure process, right? तो अभी constant pressure का equation लिखना, right? You have to write the equation for constant pressure, right? So then only we will understand what is happening, right? How can we find it? Clear? So when we write the equation for constant pressure for a closed system, du is equal to del q minus pdv और del q plus del w. pdv को इधर लेके आओ, constant pressure पे du plus pdv is dh. So यहाँ तक तो आपको पता है, right? For a process 1 to 2, right? For a process 1 to 2, heat transfer from 1 to 2 is equal to, you know, it is delta h, right? अगर हम इसको इंटीग्रेट किया तो for a process 1 to 2, total heat transfer is equal to delta h, right? लेकिन आपको याद होगा, right? If you are substituting heat transfer value in joule, this right hand side also should be in joule, ना, right? अगर heat transfer value joule पे दिया है, right, 100 joule, the right hand side should also be in joule. लेकिन the right hand side delta h और h is given in what? Joule per mole. So आपको number of mole से multiply करना ही पड़ेगा. No other go. ठीक है? So what is delta h? Delta h, I can write delta h as what? Heat transfer during 1 to 2 is equal to number of moles into h2 minus h1. What is h1? h1 is your enthalpy at state 1. h2 is our enthalpy at state 2. What is your state 1? Your state 1 is when your properties are 100, 500 and 700. Clear? H2 is the state 2. The state 2 is the state at which your temperature will be T2, volume will be V2 and pressure will be P2. For our understanding here, pressure is same. P1 and P2 are equal, right? So how can you find H2 and H1? For finding H2 and H1, they have given a relation. Clear? So they have given a relation H is equal to 30,000 plus 50T. Now what will be H2 and H1? Here itself you can see H1 will be 30,000 into 50 T1, H2 will be 30,000 into 50 T2. Clear? H2 will be 30,000 plus 50 T2 because T is the only variable. Clear? When you substitute T equal to T1, that will be the enthalpy at state 1. When you substitute T equal to T2, that will be the enthalpy at state 2. Clear? Easy? I hope you understood. Now substitute kar lo. So what is the heat transfer during that one process, constant pressure process? Heat transfer diya hai 100 joule. Number of moles we don't know. What will be H2 minus H1? H2 minus H1 will be 50 into T2 minus T1. ठीक है? So क्या क्या unknown है यहाँ पे? T1 is 500, no problem. T2 is unknown, वो calculate करना है so that we will get V2. ठीक है ना? अभी number of moles. How to calculate number of moles? Those who are not calculating number of moles, you will not get the answer correctly because हमेशा units याद रखना है आपको. Heat value is given in joule. अगर ये value joule per mole में दिया होता तो no problem, you can easily substitute, no problem. लेकिन यहाँ पे right number of moles is not equal to 1. ठीक है? So in that case आपको number of moles separately calculate करना पड़ेगा. How to calculate the number of moles separately? You know the equation, right? Number of moles is equal to PV by RT. So pressure क्या है यहाँ पे? 100 kilopascal. So 100 into 10 power 3. What is the volume? It is 700 into 10 power minus 6. R is 8.314. Temperature is 500. Now what will be the value of number of moles? ठीक है? So number of moles always आपको question में ध्यान रखना है whether they have given number of moles equal to 1 or not. अगर 1 नहीं दिया होता तो right you have to calculate the number of moles. Clear? So solve and find the value of number of moles. I think the answer for number of moles is 0.0168 mole. Right? So once you get that number of moles, substitute here. That is 100 is equal to 0.0168 multiplied by 50 into T2 minus T1 का value क्या है 500. Now calculate the value of T2. Clear? I hope up to this is fine. Right? So substitute number of moles here and find the value of T2. T2 क्या आएगा आपको? I think the T2 answer you will be getting is 618.77. 618.77 Kelvin. So this is your T2. Once आपको T2 मिल गया, substitute T2 here. Find the value of V2. What will be this one? T2 divided by T1 multiplied by V1 will be your V2. सारे values आपको पता है. T2 is 618, T1 is 500, V1 is 700 and find the value of V2. V2 आएगा आपका option B 866.32 into 10 power minus 6 meter cube, option D. I hope all of you are getting the answer. Clear? Up to this is fine. I hope all of you are getting right. Now may I go to the second question? Right, the change in internal energy of the gas in joule they are asking. Right, second question is what is the change in internal energy of the gas in joule? Right, क्या होगा change in internal energy? अभी आप options देख सकते हैं. First option is 0, right? First option is 0. Internal energy change, first option is 0. B, C, D. Right? So आपका जो answer होगा वो 0 हो सकता है if the process was isothermal. Directly 0 आप टिक करके जा सकता है, no problem. Right? But it is not an isothermal process. Clear? So you have to find it. Right? You have to find the answer now. Right? How to find delta U? You know the first law equation, right? यही equation है यार. Right? What is delta U? Delta U is the heat transfer during that process minus work transfer or PdV. right? Or we can say the integration of PdV for that process. ठीक है, it is a constant pressure process, तो pressure को बाहर ले लो, right? What will be delta U? Delta U आपको आंसर चाहिए जूल पे. Q is given as 100 joule, right? Q is given as 100 joule. Pressure क्या है? Pressure you are taking it outside, constant pressure, so 100 into 10 power 3. You have taken outside. What is V2 minus V1? V2 is 866.32 minus 700 into 10 power minus 6. तो आपका वैल्यू आएगा 83.37 जूल. ठीक है. I hope all of you are getting the answer. Is it fine? Right. So this is another problem in your closed system, right? So any day, right, if you want me to solve any other problem from GATE previous year, you can tell me, right? The one student asked me to solve this problem on board. Clear? So that is the end of our closed system, completed closed system, right? With problems, everything is done, right? But still there are some problems are there. So if you want, you can go back and check the GATE Academy previous year question booklet, right? Then solve the question, the solution, 2-3 other kind of solution. मतलब एक ही प्रॉब्लम आप 2-3 तरह से सॉल्व कर सकते हैं. You can solve it in different types. ठीक है? All the types will be available in our booklet. So go through that, right? So once you are done, we will start with our open system. Clear? So next topic is, right, next topic will be our open system. Clear? The next topic is open system. So you have to understand this is our next topic. That is, the closed system part is over, right? Now what is the difference between open and closed system, right? What is the difference between open and closed system, right? So now you can see here the major difference is what? This is the basic difference मैंने आपको बताया था, right? So definitely other than the energy transfer, you will have a mass transfer. That is, mass will come in and mass will go out. ठीक है. So whatever we learn in our fluid mechanics will be based on what? Your open system. Our pipe is an open system. ठीक है. मतलब जो पाइप के थ्रू फ्लो होगा, आप जो कंट्रोल सिस्टम की बात कर रहे हो, और सॉरी कंट्रोल वॉल्यूम की बात कर रहे हैं. So I have already told you, open system and control volume same ही है, right? Some mass will be entering, some mass will be going out, right? So we will consider this control volume and we will do our mass balance and energy balance. ठीक है. बट एज फार एज केमिकल इंजीनियरिंग थर्मोडायनामिक्स इज कंसर्न, राइट, अभी हमारा थर्मोडायनामिक्स में ओपन सिस्टम बेस्ड क्वेश्चंस आर वेरी लेस, राइट? सो द मैक्सिमम 1 or 2 क्वेश्चंस आर देयर इन केमिकल इंजीनियरिंग थर्मोडायनामिक्स इन ओपन सिस्टम, क्योंकि हम जो फ्लूइड मैकेनिक्स में मैक्सिमम केसेस वी आर डीलिंग विद द कंट्रोल वॉल्यूम ओनली, राइट? इन एवरी सब्जेक्ट वी आर डीलिंग विद कंट्रोल वॉल्यूम. सो most of your gate problems are in closed system, right? Only 1 or 2 questions are there in open system, but still we need to cover that also. ठीक है. So that is the important part. So what is the difference, right? क्या difference होगा आपका? Difference is only mass will be coming in and mass will be going out. Other than the energy transfer, mass will come in, mass will go out. ठीक है. So this is our open system. Now we are interested in what? We are interested in mass balance and energy balance, right? Mass balance and energy balance. Now we know what is the mass flow rate. Your mass flow rate is equal to density into area into velocity. What is the unit of mass flow rate? Unit of mass flow rate, you know, it is kg per meter cube is for density, meter square is for area, meter per second is for your velocity. So your mass flow rate unit will be kg per second, right? So I hope everybody know this. Clear? That is, this is your mass flow rate. Mass flow rate is equal to density into area into velocity, right? So the unit is kg per second, right? So I hope up to this is done. So if you consider a control volume, right? If you consider a control volume, right? What is the meaning of control volume? It can be of any shape, right? It can be of any shape. That is, some mass should come in, some mass should go out. So if I consider a control volume like this, any shape, right? I am saying mass flow rate 1 is entering, mass flow rate 2 is entering, and mass flow rate 3 is exiting. Mass flow rate 3 is exiting and mass flow rate 4 is also exiting. That is, there are 2 mass flow rate coming in and 2 mass flow rate going out. So आपको तो पता है what is the mass balance equation, right? We have discussed this equation in lot of question, right? Lot of subjects also. Inlet minus outlet is equal to accumulation. The same equation we are going to have, right? That is whatever sigma mass inlet minus sigma mass outlet, whatever sum of inlet minus outlet is equal to accumulation. How can I denote accumulation? D by dt of mass of the control volume. Clear? So whatever inlet minus outlet is equal to your accumulation. So mass of the control volume, right? Rate of change of mass of the control volume, that is your accumulation, right? How much it is changing. So what are the inlet mass flow rate here in this example? It is m dot 1 plus m dot 2 minus outlet is m dot 3 plus m dot 4. It is equal to d by dt of mass of the control volume. Clear? So this is your mass balance. Clear? This is your mass balance equation. That is your inlet mass flow rate minus exit is equal to your accumulation. Okay? So I hope up to this is okay. Right? Now if I bring everything that side, I am writing this as d by dt of mass flow rate or d by dt of mass of the control volume, right? I am writing it as this is an expression, okay? It is given in your Smith book, plus del of mass flow rate of flow stream. It is denoted as equal to 0. Why I am interested in this notation or this expression? Kyunki they can give this also as an expression for your mass balance in your questions, right? So they can give this in option A, B, C, D, and they can ask what is the mass balance equation. So after seeing this also you should understand it has the same meaning. Matlab, what is the meaning of this del? This del in our chemical engineering, it is, we can say it is your outlet stream minus inlet, right? Or exit minus entrance, same meaning, right? That is M3, M4 is our exit. So if you go that side, that will become positive outlet. M1 plus M2 is our inlet. If you go that side, that will be our inlet. So outlet minus inlet, that's all. So d by dt, I have kept this side. ये दोनों को उधर लेके गया, right? That's all. That is the only change. Fs means flow stream, right? Mass flow rate of flow stream. So outlet minus inlet. So this expression also they can give you. ठीक है? So based on this also they can ask question. Right? I hope this part is also clear. Now, what happens if it is a steady state process or if it is a steady state process? What is the meaning of steady state process? The accumulation will be 0. Inlet will be equal to outlet, right? Inlet will be equal to outlet. So what will happen if it is a steady state process? So this value will become 0, right? D by dt will become 0. And if I say I am having only one inlet and one outlet, right? If I have only one inlet and one outlet, we can say what? Your mass flow rate m dot 1 will be equal to your mass flow rate m dot 3, or we can say your mass flow rate is constant. When mass flow rate is constant, how can we represent it? Rho 1 A1 V1 is equal to rho 2 A2 V2. This is the case for what? Steady flow, right? For a steady flow process or for a steady state process, right? For steady state process or for steady flow cases, your mass flow rate will be constant. Which equation is this? आप लोगों ने मतलब fluid mechanics में already you might have covered this. Clear? So what is the meaning? This equation is your mass conservation equation. That is your which equation? Continuity equation, right? I hope you remember that. Clear? So this is the mass balance, right? But based on mass balance, we don't have much questions in thermodynamics. All the mass balance questions you have in chemical engineering is in fluid mechanics. Clear? So this is about our mass balance. लेकिन thermodynamics में we are interested in what? We are interested in energy balance, right? We are not interested in mass balance of open system. We are interested in energy balance. मतलब, right? What are we going to do? Already energy balance equation तो हमारे पास है first law, ठीक है? We have a first law equation, right? But वो हमने डिस्कस किया था क्लोज सिस्टम के लिए, लेकिन ओपन सिस्टम के लिए इक्वेशन क्या होगा? यहाँ पे देख लो क्या डिफरेंस हो सकता है ओपन सिस्टम क्लोज सिस्टम में. यू कैन सी हियर वी टोल्ड द इंटरनल एनर्जी चेंज of the closed system is due to work transfer and heat transfer, है ना, work transfer and heat transfer, and we wrote du is equal to del q plus del w. ये इक्वेशन था ना क्लोज सिस्टम के लिए, फर्स्ट लॉ, मतलब इंटरनल एनर्जी चेंज वाज ड्यू टू हीट ट्रांसफर एंड वर्क ट्रांसफर, du is equal to del q plus del w. लेकिन इफ आई टॉक अबाउट ओपन सिस्टम, इस इक्वेशन में क्या चेंज हो सकता है, राइट, व्हाट विल बी द चेंज? हीट ट्रांसफर भी ओपन सिस्टम में हो सकता है, वर्क ट्रांसफर भी हो सकता है, नो प्रॉब्लम, लेकिन एक्स्ट्रा क्या चीज आएगा यहाँ पे, राइट, व्हाट विल बी द एक्स्ट्रा टर्म एडेड इन केस ऑफ एन ओपन सिस्टम हियर? वन टर्म, राइट, एक टर्म होगा अदर देन दिस हीट एंड वर्क, right, other than this heat and work, you will have a mass flow rate coming in and you will have a mass flow rate going out. मतलब consider this as a water heater, right, consider this as a water heater. तो हम heat दे रहे हैं water heater को, right, you are giving some heat into the water heater, there will be work, whatever thing is there, लेकिन आपका water heater पे क्या होता है, right, what is the major difference? आपका water is coming in and water is going out. तो inlet water भी will be carrying some heat, outlet water will also carry some heat, है ना. So whenever you write the energy balance, you have to consider that also, ठीक है, that is energy carried by this inlet fluid and energy carried by the exit fluid. So both of that energy should be taken into consideration, ठीक है. So that two terms will be coming extra in this equation for open system, ठीक है. Other than heat and work, आपका जो एंटरिंग फ्लूइड एंड एक्सिट फ्लूइड, उसका जो एनर्जी है ना, सो दैट ऑल्सो वी शुड टेक केयर, ठीक है. सो इनिशियली आप अगर एक क्लासरूम के एग्जांपल ले ले, राइट, सो इफ यू टेक एन एग्जांपल ऑफ क्लासरूम, initially the classroom was closed, it was a closed system, right, it was a closed system, so the energy change inside the classroom was due to whatever heat and work transfer, that's the only process. लेकिन now both the doors are open and students are entering and going out. So the entering students' energy and the outgoing students' energy will also be taken into consideration. Clear? That's the same thing, right? Entering fluid and exit fluid. That also we should take into consideration when you discuss about open system. Clear? Clear? Up to this is fine. Now, the first thing you need to write is, we are interested in finding what is the total energy of a flowing fluid. What is the total energy of a flowing fluid? That is, some fluid is coming in, some fluid is going out. So what is the total energy of that flowing fluid? You know, for every fluid you can say, since it is flowing, there is some internal energy, right, there is some kinetic energy and there is some potential energy, right. So this three terms will be there, right, for a flowing fluid. But other than this, you have an extra energy called a flow energy, right. Other than this, you have an extra term called flow energy or flow work, right. So we will call this as flow energy because it is the energy required to push at the entrance and the exit, right. So it is the energy required to push the fluid into and out of the control volume. मतलब to make the flow you have to give some energy, right. That is the only case. यही same thing I have told in the example of enthalpy. If you remember, right, I told, for example, in some bench students are sitting, I want to make a flow, right, I want to sit there, means I need to push that particular student into that side, then only I can sit, right. For example, अगर मुझे एक bench में, right, I want to sit in a bench, right, so bench में बैठना है, what I have to do first, I have to push the, already some 5 students are present in the bench, I have to push the 5th student into that side, then only I can sit there, ठीक है. Same way यहाँ पे already something होगा, inside the control volume there is something, right. If you want to make a flow, you need to push that control volume inside and then go out. So to push the fluid in and out, you need some energy. That energy is called as flow energy. Clear? So if you want, you can write that also, what is the meaning of flow energy, right. So you can write it, the work required to push the mass into or out of the control volume, right, work required to push the mass into or out of the control volume is called as flow energy, right. So you can understand that flow energy like that, right. Now U plus PV, I can write it as what? Enthalpy. So enthalpy plus kinetic energy plus potential energy. So this will be the total energy of a flowing fluid, right? So this flowing fluid will carry this much energy when it is entering, right? What is the meaning, right? Why this particular equation is important for us? क्योंकि we are writing the energy balance of open system. मतलब आप जब open system के energy balance लिखते हैं ना, you need to know what is the internal energy change inside or what is the energy change inside an open system. It can be due to what? Entering fluid. It can be due to exiting fluid. It can be due to heat and work also, right? So the energy carried by the entering fluid is this much, right? Energy of a flowing fluid is enthalpy plus kinetic energy plus potential energy. ठीक है? Exit also, that will have the same energy. I hope you understood. Clear? So this is the first thing you need to write. Now this I am writing it in joules, right? This I am writing it in joules now, right? So if you want to write it in joule per kg, right? If you want to write it in joule per kg, or I want to write it in joule per second, so how I am going to represent this? You can see here enthalpy H. So if I write H in small letter, the unit will be in joule per kg. ठीक है? No problem. Plus kinetic energy, I can write it as what? Half mv square, but I am writing it as half v square. Plus potential energy is mg into z, I can write it as gz. So what will happen? Every unit is in joule per kg. ठीक है? Because half mv square divided by m is our joule per kg. mgz divided by m is our joule per kg multiplied by mass flow rate. So what will be the equation? Mass flow rate is in kg per second. So this is in joule per second. Clear? So I have written the total energy transport, right? So total energy transport of the flowing fluid, right? So this I can say it is the energy transport of flowing fluid, right? If you have a flowing fluid, this is the energy you have, right? This is the energy carried by a flowing fluid. So this up to this is fine. So write this. We will go for the next part. Clear? Up to this is fine. Now I'm going to write the equation, right? Now I'm going to write the final equation for energy balance. Clear? So what was the general energy balance for closed system? Closed system का क्या था? Internal energy change is equal to, no problem, ठीक है ना? यहाँ तक तो ठीक है. So this is in joule, this is in joule, this is in joule, right? But in open system you have a flow, so we will represent everything in what? Joule per second. That is the only change here. ठीक है? यहाँ पे आप देख सकते हैं. What will be the equation? You can see here d by dt of, right? That is the change in the internal energy. So I am going to write it in energy. So mass into internal energy, right? Internal energy is in, if you want, kilojoule per kg, right? Kilojoule per kg. So or joule per kg, kg cancelled out. So this will be in, for example, those who have confusion, this is the internal energy U, m into U. U is in joule per kg, mass is in kg, kg cancelled out, joule per second. So the unit of this equation is in joule per second. No problem. The rate, whatever change inside the open system is due to what? One reason for the open system is again heat and work, same as that of closed system. So I am saying this is in heat, this is in work. Why I have represented it as q dot and w dot? Because हम लोग जो लिख रहे हैं ना, that the unit is not in joule, we are writing it in joule per second, right? So that is the only thing, because we want to write everything in the same unit, right? That's the only thing. Now plus क्या होगा? Your inlet energy of the flowing fluid minus exit energy of the flowing fluid, or outlet energy of the flowing fluid, right? That is the energy carried by the inlet and energy carried by the outlet. So uske liye already we have an equation, right? Already we have an equation. So this total term at inlet minus this total term at the exit, that will be your final equation. Clear? I hope that part is okay. Now you can see here, if I take that exit and inlet this side, if I bring that exit and inlet this side, that will become what? Outlet minus inlet. So I am going to write this one again, d by dt of m into u of the control volume plus exit minus inlet, I am writing it as del, that is outlet minus inlet, right? Del into mass flow rate multiplied by h plus v square by 2 plus g set is equal to what? Q plus W, right? So this is your final equation of closed system, right? This is your final equation for closed system energy balance. Simple, right? Simple. This is what? Del represents outlet minus inlet. So if you want to elaborate the equation and if you want to write it again, it's very simple. You can write like this also, right? It is outlet minus inlet, right? Let me say it is outlet minus inlet. So H outlet minus inlet will become what? H2 minus H1. V2 square minus V1 square. Same that way also you can write it, no problem at all, right? Now, so this is the general energy balance equation, general energy balance equation for open system. Done. I hope up to this is fine. Clear? Now, what is the next change here? Next change is, if it is a steady flow device, right? If it is a steady flow device, right? What will happen? D by dt term will be cancelled if it is a steady flow device. So what will be left? Only del of these terms will be left. Clear? So that also I hope you can understand. Right? 1 minute. Right. So I hope you understood that as well. Clear? That is d by dt of this term will be cancelled for a steady flow system. Done. Now, then what will be the equation if it is a steady flow device, right? For steady flow devices, what is the steady flow device? We will discuss later with examples. For steady flow devices, d by dt term will be cancelled. So del is your outlet minus inlet. So I can write this as mass flow rate into H2 minus H1 plus V2 square minus V1 square by 2 plus G into Z2 minus Z1 is equal to heat work. Clear? So this will be the equation for what? Steady flow devices. I hope that part is also done. Clear? So this is the general equation. Now, right, what changes? Right, आपके जो question में आपको कैसे solve करना होगा? Right, if it is an open system problem, simple है. Right, they will give you in the question like what are the terms which are not present in that particular problem. Sometimes वो दे सकता है there is no heat transfer, then ये zero हो सकता है. There is no work transfer, ये zero हो सकता है. Right, and they can say steady flow, this also zero. If they say kinetic energy, potential energy negligible, ये दोनों cancel हो सकता है. Right, so based on this you have some questions in gate. ठीक है, and steady flow devices based questions are very less, maximum one question is there, right? We will solve that also, right? So this is the your energy balance equation required for open system. Clear? Now this is a question in your Smith and Van Ness book, right? Smith and Van Ness book, right, for thermodynamics 7th edition. So you can see in the latest edition, right? In the latest edition, they have given our new sign convention, not the old sign convention. They have given the new sign convention, that is minus PdV is given in our new edition. So you can see here minus PdV is given for new edition. In old edition, they have given PdV, right? That's the reason I am teaching this minus PdV sign convention, right? So we will see one question now. That is in open system, only one question is given in your Smith and Van Ness book. So this is the question, right? So read the question carefully. An evacuated tank is filled with gas from a constant pressure line, right? An evacuated tank is filled with gas from a constant pressure line. What is the relation between enthalpy of the gas in the entrance line and internal energy of the gas in the tank? Okay? What is the relation between enthalpy of gas in the entrance line and internal energy of the gas in the tank? Neglect heat transfer between gas and tank. Clear? I hope this is done. Clear? So this was the problem. Now let me write the question once again. You have a insulated evacuated chamber, right? That is evacuated tank. So it is an evacuated tank. What is the meaning of evacuated tank? You have vacuum present inside this. Now with a constant pressure line, we are filling a gas against vacuum. Right? We are filling a gas against vacuum. Filling the gas against vacuum is what? Free expansion. Lekin this is not a closed system. Right? Free expansion was a closed system process. Matlab, there was no inlet. Right? There was no inlet in free expansion. Ek side pe vacuum tha. Right? One side it was vacuum, another side it was gas. Now the partition is removed, so gas is filling against vacuum in a closed container, right? But here it is not a closed container. What they are saying is, it is an open system, right? That is, you have a tank and you have an inlet. So through this inlet, we are filling some gas. Clear? So I hope you understood what is the difference between free expansion and this question. Okay. So now once again I will read the question. An evacuated tank is filled with gas from a constant pressure line. What is the relation between enthalpy of the gas in the entrance line? That is, gas is coming in. What is the relation between enthalpy of this gas and internal energy of the gas in the tank? Internal energy of the gas in the tank. This is the question. So first of all, you have to find what? You have to write the energy balance equation for closed system. You already written, right? Closed system, sorry, open system. This is the open system energy balance, no problem. Now, you can see here, what are the terms that will be cancelling? First of all, right, in the question they have given kinetic energy, potential energy are negligible. Since that is given, V square and GZ terms are cancelled out. Clear? They have given it in the question, okay, kinetic energy, potential energy. If you want, I haven't shown that particular note, right? And they are saying that they have solved the question based on one statement. If kinetic energy and potential energy are negligible, so I am cancelling both. Clear? Now in GATE they will give you both cases, right? Kinetic energy, potential energy. Now they have said in the last line of the question, that is neglect the heat transfer. So heat transfer is cancelled. Since the gas is filling against the vacuum, so there is no work done. Already अब हम लोगों ने free expansion में पढ़ा था, है ना? Right? That is 0, 0, both cases 0. Right? Since it is against vacuum, both are 0. Now, what are the terms which is left now? You can see here, d by dt of mass of the control volume into internal energy of the control volume, right? So this m into u is equal to del. Can I write del as what? Outlet minus inlet. If I bring this side, it will be what? Inlet minus outlet. है ना? Del if I bring that side, inlet minus outlet, right? Outlet minus inlet की जगह पे. Do you have any outlet in this question? No. So there is no outlet. Only inlet is present. Right? Only there is an entrance line. There is no exit line. So cancelled. Now, what are the terms left at the inlet? It is mass flow rate multiplied by enthalpy at the inlet. Right? Mass flow rate multiplied by the enthalpy at the inlet. Up to this is fine. Clear? Now what is the mass balance equation? Mass flow rate is equal to dm by dt, right? Mass balance, so d by dt of mass into internal energy of the control volume is equal to enthalpy into mass flow rate. Can I write mass flow rate as dm by dt? No problem. Now it's simple, dt cancel, right? Or do the integration, you will get the answer of what? Del of the change in m into u is equal to enthalpy into change in mass. From process 1 to 2, can we write it as m2 u2 minus m1 u1 is equal to inlet enthalpy multiplied by m2 minus m1? Can I write this? Simple, right? For a process, initial state and final state, m2 u2 minus m1 u1 is equal to like this. Can we write like this? Now initially it was vacuum ना, initially vacuum present था. अगर vacuum है तो mass क्या होगा? Zero. Initial mass तो zero हो गया ना, right? अगर initially vacuum present है तो gas का mass क्या होगा? Zero, right? So m1 m2 everything is cancelled. So when can we write m2 into u2 is equal to m2 into hi. m2 m2 cancelled out. Final internal energy is equal to inlet enthalpy, right? Final internal energy is equal to inlet enthalpy. This is the final equation you are getting. This is the relation between enthalpy and internal energy in case of this, right? लेकिन आप can you understand this logically? Logically आप ये समझ सकते हैं ना? Simple है ना? मतलब initially vacuum है, कुछ भी नहीं है, मतलब initially there is no internal energy. तो final internal energy क्या होगा? The enthalpy coming in, right? Initially, right, for example, you have not eaten anything, right? So the stomach is empty, right? So final internal energy left here, right? After eating one banana, what will be left inside the stomach? One banana, the same thing, right? That is, initially it was vacuum, nothing was present. So the final internal energy will be what? Whatever enthalpy coming in. Clear? So this is the meaning. So U2 is equal to HI. Done. So this is the relation. So this is the question, right? This is the question given in your Smith and Vannes book. Now you can see, for example, this is the question 2.13 given in your Smith and Vannes book. The same question is repeated in 2012 IIT Delhi. That is, an insulated evacuated container is connected to a supply line of ideal gas. Same thing, no change is there. And you can see it is filled with gas until the pressure reaches the container PS. Right, there is no heat transfer, kinetic energy, potential energy negligible, Cp, Cv are the heat capacity, then final temperature of the gas in the container is, right, what will be the relation? This is the question. Clear? Now how to solve it? It's very simple. They are asking the relation between final temperature T2 and initial temperature Ts. Simple. What is U2? U2, can I write it as internal energy, right? For ideal gas, Cv into T2. What is H? Enthalpy. Cp into inlet temperature is Ts, right? Cp by Cv is gamma, so T2 is gamma times Ts. Clear? So the problem is solved. So you can see the same question in your Smith and Vannes book is repeated with a small change, right? So they have not asking the same relation. They have just changed the question. Okay? So this is your open system, right? This is the only question in GATE so far in chemical engineering in the last maybe 15-16 years from open system, right? एक ही question आया है, right? So depends on how much you are practicing based on open system, क्योंकि last 16 years से अभी तक, right, closed system से ही question आया है, right? So open system questions have been very less, but still you have to practice it, right? But you need to remember how much weightage is there for these kind of questions, क्योंकि हमेशा क्या हो जाता है, I have seen this with all the test series, right? People will be taking questions from mechanical engineering and putting in the chemical engineering, right? And so what happens is mechanical engineering, they have lot of questions from open system, right? But in chemical, we don't have that much weightage to open system, right? So that also you need to understand. Clear? So these are the part left for open system. Now with some small topics like throttling devices and turbines, basic turbines, etc. is required for chemical engineers as well. So that we will discuss in the next class. Right? With that, that chapter will be over. Then we can start our second law of thermodynamics. Clear? So these are the part for open system. That's all. We'll see you tomorrow for the next class. Thank you.